So we have completed get functionality as well on a singly linked list, right? Now let's try to perform a set functionality on a singly linked list. So what exactly a set functionality does is, as the name indicate, it's basically used for updating the value of a particular node. So as part of this implementation, what exactly we will do is we will try to take the index and we will also try to take the new value for the node. So as part of the set functionality, what we will do is we will try to reach the node that is available at the index given by the user, and whatever the value that we had in that node, right, and we make sure that we are updating that value with the new value. So that is the set functionality on a singly linked list, which is basically used for updating the value that is available at an index that is given by the user. Okay, since we are taking the index from the user, right, we know what all are the possible indexes for the singly linked list nodes, and it will start from 0 and it will end at length of the linked list minus 1. That means the indexes of the singly linked list that you see on the screen will be something like this. So as part of the set implementation, let's say the index that user gives is, let's say, 3. I want to update the node that is available at index 3 to a new value, let's say some text ABC. What we have to do is we have to reach the node that is available at index 3 and we have to update the value that it currently has is test, right, and we have to update the value to ABC. So that is the main purpose of the set functionality. So what all are the different cases that could come? So obviously, just how we implemented in the case of get functionality, right? Whenever we are taking the index from the user, basically there could be two scenarios. One is the index that user is giving is valid index, or it could be a invalid index. And based on the value, new value, we don't have any restrictions, right? Singly linked list should store any value as part of the node's value. So there is no validation on the value that user is passing. The only validation that we have is in terms of the index that user is passing. So the different cases would be, first would be to check if the invalid index, and the second condition would be to check if the valid index. Okay, so we have to handle these two scenarios, right? But the thing is, by handling all those scenarios, we have already implemented a functionality called get functionality, right? And it will basically take the index, and based on if the index is valid or not, if it is a valid index, we will return the node that is available at that particular index. If the index is invalid, we will simply return null or none based on the programming language that we are using for implementing. In the case of Python, we will simply return none. In the case of Java or JavaScript, we are going to return null. So we are returning the entire node object. That means that node object that we are going to get as part of the get functionality will return the entire node, right? That means it will have the reference to the next node and it will have the value as well. So if we can simply reuse the get functionality, we can simply update the node dot value with the new value that user is passing. We can simply update the value of a particular node. So we don't have to write the logic that basically handles invalid index and the valid index, the iteration logic that we have to write, right, to go to that particular node. The similar logic that we have written in the case of get functionality, we don't have to write all those things, and we can also basically reuse one of the functionalities. That is the main purpose of implementing any function, right? So we can simply reuse the get functionality here. So how will we reuse? We will simply call the get function with the index that user is passing. If the get function returns null or none, that means that it is a invalid index, because in the case of get implementation, if you remember, we will only return null or none if the index is invalid. Otherwise we would obviously return the node. this basically indicates that it is an invalid index. That's why we will simply return false, indicating that we haven't updated the node. Okay, otherwise if it is not null or not none, we have actually written the node, right? On that node, it is a singly linked list node of type node that we have defined. As a result, we can simply use that node dot value equal to new value. In this, by doing simple operation, we will be able to update the value we have in the node that is given at the index that is also given by the user. Okay, so that is how we reuse the get functionality for implementing the set functionality on a singly linked list. Okay, I hope things are clear to you. So far we have seen how can we implement the set functionality on a singly linked list, right? And the way I explained the logic is almost similar to how we write the pseudocode only, but anyway, go ahead and let's try to write the clear pseudocode for this. Okay, so as part of the set implementation, what exactly we will do is we will write a function called set, and here we will be taking two arguments from the user. One is index and the other will be new value that we want to use for updating the node's value. So obviously, as part of the set implementation, immediately as soon as index is involved, right, we can simply call the get functionality that we have already implemented, and we will simply store it in one variable called node or something, right? And this get functionality is already implemented for valid indexes as well as invalid indexes. So in the case of valid index, it will simply return the entire node object, and in the case of invalid index, it will simply return null or none. If we are using Python, it will simply return none. If we are using Java or JavaScript, it will simply return null. So whatever the node return value that we are getting from the get functionality, right? If this node is null or if it is matching with none, that means that it is an invalid index. Here we can simply return false, indicating that we haven't updated the node because the index is invalid. So obviously we will not have the node at that index given by the user. If it is not equal to null, right, that means else block, what we will do, we will get the entire node object. So on that node we have dot value, right? We can simply read value of that particular node and we can simply assign new value to that. So how will we do that? So we have the node inside the node variable and we can simply do node dot value equal to new value that user has passed. In the end, we can simply return true, indicating that the updation is successful. So that is how we write the pseudocode for the set functionality on a singly linked list. One thing that you have to understand here is, here our logic is completely based on the get functionality, right? So after that we are simply checking if it is a valid or invalid index based on the return type of the value, and we are simply returning true or false, and we are simply assigning new value to the value variable we are maintaining inside a node if it is a valid index that is given by the user. So obviously as a result, the overall time complexity and space complexity will be exactly similar to what we have inside the get functionality, because the overall time complexity of set implementation will become the time complexity of get functionality plus whatever the additional logic that we are writing. As part of the additional logic, if you see here, right, all the logics that we are doing are simply checks and assignment operations, and obviously they will take only constant amount of time. As a result, the overall time complexity will be similar to get functionality, and the overall space complexity will also remain similar to the space complexity that we have in the case of get functionality. Okay, so that is what we have in terms of writing the pseudocode for set functionality on a singly linked list. So for this, I'm going to define the function name as set, and the arguments will be index of the node that user wants to set the new value, and the new value of the node also I will be taking from the user. Okay, if you remember the pseudocode that we had discussed earlier, right? So as part of this, we have to go on to the node that is available at this specific index, and we will have to update the value that is already available with the new value that is given by the user. So if you remember that, going and getting the node available at this index is nothing but the get operation that we have already implemented. So, and this get function also will return the node available at that particular index if it is available, if the index that user has given is valid one. Otherwise, we will simply return none. So based on this case, we will be able to reuse the get functionality here. So as part of the first step, what I will do is I will call the get function with the index that user has given. Okay, and let's just whatever the result this get function is going to return, I'm storing it inside the variable node. Now if the index is valid one, then we would have had a actual node that is available at this index given by the user. If not, we will have the none in the node, because we are returning none in case of if the index is invalid. So if node equal to none, that means that we will not be able to update anything. So we will simply return false in that case. Okay, otherwise that means user would have passed the valid index. That means we would have gotten a valid node available at that particular index. So we need to update the value at this particular node. So how will we do that? We'll simply do node dot value equal to new value that user has passed. Okay, here since we are able to update the node's value with the actual value that is given by the user, we will simply return true, indicating that we have updated the node's value. Okay, very simple operation. That's all the implementation of set operation. Basically, we will call the get functionality with the index that user has passed. If the node that is being returned by the get functionality is a valid one, then we will update the value of that particular node with the new value. If it is an invalid one, we would have gotten none in the returned value. In that case, since it is not a valid node, then we will simply return false. Okay, now let's just try to perform this operation and validate it. So let me just comment out these two functions, and let me just uncomment these two. Okay, let me just call the traverse function before setting. Okay, before setting, let me call the traverse, and after setting sll dot set of, let me just pass the index. Let me just say I want to update the value at index 1 with the new value of, let's say, my name. Okay, and after setting, let's traverse once again. Okay, let me just comment out this head and tail, because we are not doing anything with respect to head and tail in the set operation. So if I execute it, the node at index 1 is codingpal.arc here, right? It should get replaced with the value Sai. Okay, if I simply go on to terminal and if I execute it, right, let me just clear this out. Let me just pull this down a bit. Okay, let me just try to run python 3 singly linked list.py. Okay, before setting, we are traversing the linked list. So we have got the values 10 codingpal.arc, true, and 1. And after setting, we are traversing once again. In this case, if you observe here, the value at index 1, that is codingpal.arc, has been updated to new value Sai. Okay, similarly, you can perform if I try to give an invalid index, since we have only 4 values, that the possible indexes are from 0 to 3. So if I pass any invalid index, which is 10 here, if I pass it, it should not update anything. So before setting and after setting, the result should remain the same. If I execute it, if you observe here, we have the same values before and after setting. Even if you try to print the head dot value and tail dot value also, let's say I want to update the value at index 3. Right now, tail, which is at index 3, is 10.0, right? Let me just update the index 3 value with the Sai. So obviously the tail we are updating from 10.10 to psi, right? So if I print it, we should see the same thing getting reflected too. Okay, so the last value 10.10 has been updated to psi. As part of this print, the head value is still 10, which is the first value or the value at 0th index, and the last value that is at index 3 is psi. Okay, even though we are not specifically updating the tail or head manually, the get functionality is making sure that it is returning the value at that particular node, and we are setting the value, right? That's why it is basically updating the value available at that particular node. Okay, this is how we basically perform the set operation on a single linked list. Just to recollect, we are reusing the get functionality, and by reusing the get functionality, we are simply updating the value available at that particular index. Okay.